Hey there, physics fans. We have a little projectile motion for you here. And let's see if we can't solve this question about a pool ball leaving a table with an initial velocity of 2.4 meters per second. We want to know the time for the pool ball to fall to the ground and then the horizontal distance that it travels. Well, first off, let's see if we can't draw a picture of what we've got here. We've got a table, and it looks something like so, right? And it's got two legs, and they come down. Let's make them like this, and like so, right? And we've got a pool ball on this table, and so it looks like so. And this pool ball is traveling off the table, and it's got a velocity, and its velocity is 2.4 meters per second. Well, this question's a nice question because it holds our hand a little bit. It asks us for several pieces of the puzzle that will get us to our ultimate answer. You see, it tells us we have a change in distance vertically. And that vertical change in distance this way is 0.6 meters. So this delta D equals 0.60 meters. Now, the time it takes to fall that distance is equal to the time that it's going to travel horizontally. Because what's going to happen is the thing is going to travel in a portion of a circle. It's splat, right? It's going to go just like so. But the vertical time is equal to the horizontal time. So the trick is we can get the actual time from the height that the table is, because the ball is going to fall that height. So I'm going to say, all right, well then how can I find out time knowing change in distance and also knowing that gravity in the vertical realm is negative 9.8 meters per second squared? I can say, well then delta D equals 1/2 a change in time squared. And therefore I rearrange this a bit and I end up with 2 change in distance all over a square root of equals delta t. We can put some numbers in here and we can find out our answer for time, which is the first part. It says predict the time required for the pool ball to fall to the ground. And so let's put some numbers in here. I would say, well then 2 times 0.60 divided by negative 9.8 meters per second squared. And make sure this distance is down so it itself is negative. If you didn't make that distance negative, then you wouldn't have 2 negatives under the square root sign, and you wouldn't be able to, well, find the square root of a negative number. But those 2 negatives cancel each other out, and you do this workout, and you get 0.35 seconds. Quite a useful time indeed, because we're going to use that time to find out the horizontal distance that we traveled. Because the horizontal distance is a question of v equaling delta d over delta t. Because that 2.4 meters per second is constant. It doesn't change because it accelerates vertically but not horizontally. So now we want to know the delta d. We know the t and we know the v. So we can multiply v delta t equaling delta d. And so we end up with our 2.4 meters per second times our time of 0.35 seconds. And that'll give us our final answer, which ends up being 0.29 meters, which is 29 centimeters. That's my final answer. Thanks for